Okay, here we go. So we're talking X and Y intercepts. So Y-intercept is at 0, 3, X-intercept's at -3, and we found the slope was 1, just to recap. Okay, cool. All right, so now let's graph a line. Okay, so see how we have y equals 2 over 3x minus 5? If you guys had to graph this line right here, if you had to actually graph it on a graph, on a grid, how would you do it? What's the first thing you would plot? Y-intercept, sounds good. So here's our y-intercept, -5. Let's plot that on our graph. 1, 2, 3, 4, 5. It's all the way down here. Okay, once we plot the y-intercept, then we can use the rate of change to get our next point. So 2 over 3 is our rate of change, or our slope. So we can use 2 over 3 to figure out the next point on our graph, right? That's one way to do it. So we could go up to 1, 2, and over 3. 1, 2, 3, and that would give us our next point. And we could continue that pattern, except I'm gonna run out of room because I have the smallest grid in the world. And that would be the equation of, that would be this line. Guys, what's another way you could graph this, like this equation, if you didn't like that method? Anyone have a different method for how to graph a line? I feel like something else could work. Rhymes with cable. Nobody? Table? Yeah. Yeah, Lizzie. I mean, you could make a table of values, but that seems kind of annoying. Like, for example, you could sub numbers in for X and figure out what Y equals. Yeah, you could. Okay, but I feel like this method's easier. Okay, so let's graph this blue line. Y equals -2x minus 4. Okay, so first we plot our y-intercept, -4, on the y-axis. So 1, 2, 3, 4, done. And then we use our rate of change to find the next point. And if our rate of change is a whole number, like -2, you can change it into a fraction by putting it over 1. And that tells you the rise and the run. Okay, if it's -2, how is that going to change your line? Like, how are you going to get the next point? Yeah, it's negative. So since it's negative, we know the line has to look like this, right? It has to slope down to the right. That's what negative lines look like. So we're still gonna go up 2 over 1 because we can't really go down 2 over 1 or we'll be off the graph. So we'll still go up 2, but this time you'll have to go over 1 to the left, because our line's gonna be sloping like this way. If we went this way, then it would be a positive slope. And then we can keep our pattern going, up 2 over 1, up 2 over 1. Yeah, exactly. The line will be decreasing to the right. You got it. So that's how we would sketch it. So that's, I don't think I ever went over this. I can't really recall, to be honest. But that's how you graph a line from an equation. So if somebody gives you an equation, you could graph the line. Apparently so can OneNote. Okay. So you always start with the y-intercept. And then from the y-intercept, you use the rate of change to get the next point. Okay, how are we feeling? Confused? Okay. I feel like I need a back channel anonymous way to post. If you're like, what? Any questions about this? What if you have a large scale with large numbers? Do you mean like, okay, would you still be using all 4 quadrants? Like, can you give me an example of an equation? Are you saying like, what if you had to plot like y equals like 100x plus 200? Oh, yeah. Good question. I would use technology because that seems horrible to graph by hand. But if you had to graph it by hand and you had a teeny tiny grid like this, that would definitely be unfortunate. So if you have a large, okay, 100x plus 200, and I wanted to graph this, I guess I'm gonna have to change my scale, like you were saying. Can't really go up by ones, you'll never get it. So say I went up by 50s. You can totally do, oh, that's not gonna be great. Put that down there a little bit. You do it the same way, it's just like annoying. Yeah, I would use Desmos too. Yeah. We'll never make you graph these horrible numbers by hand. It's not really, like, nobody does this, you know? It's not really efficient. You have to really think about your scale, right? So if I know my y-intercept's 200, so I would plot that. And then I know if my rate of change is 100, so 100 over 1. So I know I have to go up 100 and over 1. So I would purposely make my x-axis increase by ones, right? So you just got to think out your scale to like, what's the easiest way to graph this? So 100, up 100 over 1, like up 100 over 1, down 100 over 1. Because I would graph it like that. But yeah, like you said, I would totally use Desmos. Oh, you can't even see it. Sorry, guys. I forgot, like, I'm doing it on my iPad. You can't even see what I'm doing. Sorry, I was totally graphing the whole time. This is my graph. I was saying I would pick a y-axis that went up by 50s. And then I would choose my x-axis to go up by ones, just because I know I've got a rate of change of 100 over 1. But yeah, ideally I would use a graphing calculator or something if the numbers are really big. Or just, yeah, try to pick a scale to make it easy. Sorry, I keep forgetting I'm totally using my iPad and my laptop at the same time. Okay. But what if you have an equation that looks like this and you want to graph it? So 2x minus y plus 5 equals 0. Let's say you want to graph this guy. What would you guys do? Because I can't really tell what the y-intercept is or the slope. How would we graph this? Yeah, you could change the form of it, for sure. Okay, so I just want to show you 2 methods. I'm almost done. Okay, so method 1, convert to slope-intercept form. Yeah. Good call. Okay, so if we wanted to convert this to slope-intercept form, I think the easiest way would just be to move the y to the other side. So I'm going to add y to both sides. So that leaves me with 2x plus 5 equals 0 plus y, which is just y. Boom, one step, done. Okay, so I converted it to slope-intercept form. And now I can easily tell, oh, my y-intercept's 5. So 1, 2, 3, 4, 5. And my slope is 2, or 2 over 1. And I know it's a positive slope, so I know it's going to slope up to the right. So if I go down 2, I have to go left 1. Down 2, left 1, down 2, left 1. So that my line can slope up to the right. So I just use the rate of change to help me go down 2 and over 1. So you could totally use the same method we've been using. Or, alternatively, you can use a different method. Method number 2. You could use X and Y intercepts. Let me know if you guys ever can't see my screen. Okay, so what that means is you could actually find the X-intercept, I'm just gonna erase my line, and then the Y-intercept and plot them on the graph. And you do that by subbing 0 in. Okay, so check it out. Let's say first we're gonna find the X-intercept. Okay, so what do we know about the X-intercept? We know it's where the line crosses the x-axis. So we know that actually y is equal to 0 at that point. Right? You guys proved it like up here somewhere. So yeah, see, x-intercept, y is equal to 0 right at the x-intercept. Are we good with that? Y is equal to 0 at the x-intercept? No one's sleeping, are they? Okay, so you just take your equation, 2x minus y plus 5 equals 0, and change the y to a 0. So it becomes 2x minus 0 plus 5 equals 0. And now just solve this equation for x. So 2x minus 0 plus 5 would just be plus 5 equals 0. Let's get rid of the 5. So we subtract 5 from both sides. So we get 2x equals negative 5. And final step, divide by 2. So those cancel out, so we get x equals negative 5 over 2, or negative 2.5, I guess. And now we can plot that on the graph. So negative 2.5 would be right here. Does that make sense? This is weird. We already know the y-intercept because we found it before, but let's say we wanted to still find the y-intercept. Am I still sharing? Just want to make sure. Okay. Okay, let's say next we wanted to find the y-intercept. Now we just set x equal to 0. Because at the y-intercept, x is 0. So we do the exact same thing. 2x minus y plus 5 equals 0. But this time we stick a 0 where the x is. So 2 times 0 is 0. I think I'm just going to get rid of it because who cares about the 0? And then negative y plus 5 equals 0. If I just add y to both sides, then I get 5 equals 0 plus y, which is y. So I get the y-intercept is 5. 1, 2, 3, 4, 5. And then I can plot that on and I can make a line. So I know, oh, I'm so sorry. My thing didn't keep going. Anyways, here's how I found my y-intercept. So I subbed 0 in for x, got rid of 2 times 0 because it's just 0. And I had negative y plus 5 equals 0. So I added y to both sides to get rid of it. So I just ended up with 5 equals y. You could have also gotten rid of the 5, but then there's this silly negative in front of the y, so you'd have to get rid of that too. And then I found my y-intercept. And then I can actually plot my x-intercept, my y-intercept, and make a line between them. So there's like 2 methods to graphing a line. What's your favorite method? Slope-intercept form or x and y-intercepts? Or neither? Table of values. Did I put you to sleep yet? I'm sorry. Guys, I feel like these 40-minute lessons are making me like a really boring teacher. I swear, in person, I used to have fun. Like when it wasn't COVID. I'm sorry. Are you guys still there?
Yes.
Okay, good. I feel alone. Okay, here's your goal. Can you find the x and y intercepts and graph it for this line right here? You guys try. Okay, good. Thanks for answering, guys. I just want to make sure. Okay, so yeah. You guys try. See if you can find the x-intercept and the y-intercept for this line.